Hi there, it's been a few weeks and I have a big announcement to make. So sadly, after 4 years of working for Ford Motor Company, I've sadly had to leave for personal reasons. I absolutely enjoyed working for Ford Motor Company and had awesome colleagues and an awesome boss. I felt very lucky and privileged to have been able to work with the only quarter car test rig that I'm aware of within the Ford world, doing research into suspension controls. And to commemorate my time with Ford, I am now taking some time to look back on a project that I'm very proud of from when I was working for Tenneco, who is nowadays known as Drive, but back then they were known as Tenneco. And this was the very first project that I was put in charge of. So I worked previously on other projects for Tenneco, but in a supporting role. This was the first where I had the project lead role, and it's something I'm quite proud of. So previously I made a video on how I was proud of winning the small solar car student competition. This is kind of a follow-up to that, but yeah, with somewhat more serious consequences. So very quickly, Maslow's triangle. You're most happy if you're able to reach self-realization, and this is one of those projects where I felt that was the case. Quite quickly, I've been involved in car setup in some form for past 19 years, and after graduating engineering school, this project with a switchable damper on the Ford Focus RS was something I was quite proud of in my time working for Tenneco. So how does this relate to racetrack setup? So besides providing dampers in production cars, also our structural components, especially if it's a McPherson strut, which is very widespread, very widespread design. It's used in many vehicles. Dampers also have to limit the rebound travel of suspensions with the rebound stop, and they also limit the bump travel by interacting with what's known as the jounce bumper or spring aid or bump stop. And besides bushings, the rebound stop and spring aid also contribute to suspension rate, obviously besides the mainspring. And dampers are notoriously difficult components to tune. So two dampers with nearly exactly the same force velocity curve can feel very different, while two dampers with very different looking force velocity curves can feel very similar. So the very first challenge which had to be overcome in the Ford Focus RS project was an issue of damper tuning. So this damper was a switchable damper. So here in this picture you see a demo damper which was given to me by my wonderful colleagues, ex-colleagues at Tenneco, as a parting present. Here you can see the cutaway where inside you see that there's a electrically controlled valve which controls the flow through some passive valves, and of course to be able to power the electrical valve you need some electricity, so there's a wire coming out of damper rod. So the issue was you have one setting, say a firm setting, coming from one set of passive valves, And then you have, once you open up a bypass through another set of passive valves, you have a softer damping setting. But there is certainly some interaction between the two settings. So if you change the firm setting, then the soft setting would be affected, both in terms of the low speed damping and the high speed damping. So this meant that anytime you change the firm setting, then the soft setting is affected as well. Changed meaning if you change the hardware tuning of the shim stack and the bleeds through this shim stack and so on. This made it a bit challenging because Ford had quite extreme targets for this vehicle, and you only have this one fixed spring rate, but you have two different damper settings which need to feel quite distinct, and both need to be extremely sporty. So the challenge is then to generate sufficient differentiation between the two, but still have both damper settings work. And of the two, of course, the easier of the two to tune properly is the softer of the two. So you'd want to start with that, but then the issue is the firm setting, which was then tuned later, would then obviously affect the softer of the two settings, which makes the tuning rather difficult. And as right at the beginning of the project, there were not that many people working on the project. It was just myself, technician, mechanic and technician, designer. So not a very large team. And for the tuning sessions, Tenneco obviously has specialized damper tuning engineers who go along with tuning sessions to take care of damper tuning, and these are typically booked well in advance for customer projects. But the Focus RS project was not a regular customer program, so it was a new damper technology for Tenneco which wasn't launched yet, and Ford were simply exploring the possibility of whether it could fit with the Ford Focus RS, and it was not a sure thing that it would come on the vehicle, and so it had to be sold to Ford. Ford had to be convinced, Ford management had to be convinced, and after the first week of damper tuning, the vehicle was not in a state to convince Ford management. And at that moment, there was a impending Ford management drive, but then there was no ride engineers from Tenneco available, so I took so then I volunteered myself, thinking that in terms of cooperation that I would be requested to provide, say, less low speed damping or less mid speed damping or more high speed damping, but surprisingly it didn't actually go like that, and I had to try and decipher from the vehicle dynamics engineer or a vehicle dynamics specialist from Ford. From his comments, I had to try and figure out where in the damping I had to change. So it was a stressful week. Luckily, I had the help of a very experienced ride engineer from Tenneco who was working on another Ford project during the same week in another damper tuning van, and was able to get advice from him, and managed to come up with a damper setting which ended up passing the Ford management drive. So that was the first hurdle. After that, the project really ramped up in terms of workload, because then Ford were a lot more invested in trying to get it onto the Ford Focus RS, but more hurdles. There were many more hurdles to come. And just a word on why in damper tuning, with two dampers having similar force velocity curves, why they might feel very different. The reason is, so this force velocity curve that you see here is typically made up from measurements done at different damper velocities, but such testing is done with the sinusoidal input. So nice, just a single frequency, nice and smooth, and the damper force at the peak velocities are then taken to generate that plot. The issue is, in real world, you don't have a nice sinusoidal input. You have a very stochastic input with a broad range of input frequencies. So obviously, of course, you have the body eigenfrequency and the wheel hop frequency, but there are also other frequencies in between and around those going into the damper as well, due to the road input. So a more recent trend is to try and come up with more sophisticated damper testing techniques to be able to better predict what the damper will actually, how the damper will actually perform. In the past, companies would just do sinusoidal testing, but nowadays companies are moving towards more sophisticated testing at different frequencies, different amplitudes, and so on. So the next hurdle that had to be overcome was the rear packaging. So the rear damper rod on the regular Focus poked through a small hole in the vehicle body, so from the rear wheel wells into the trunk. And so if you take a look at this picture here, that's the rear top mount of a regular Mk3 Ford Focus, including the ST. And so this is the damper rod. It's attached to this thing which is called top mount. It's not solidly mounted, but it's isolated using this rubber part. And this rubber part also presses against the vehicle body, so the outside lip creates a seal with the body. But this bit pokes through a little hole in the vehicle body. So what's the problem there? Well, as mentioned before, we have a control valve which needs electricity, and this means that you don't have the thin rod anymore. The damper rod becomes a lot thicker. But when the damper rod becomes a lot thicker, the nut also becomes bigger, and those, if they were mounted in the same location, would not poke through the same hole anymore. The hole is too small. Plus, due to the rubber, the damper rod vibrates due to the forces from the damper, and that might knock against the vehicle body, which obviously would create a lot of noise and not be acceptable. So the solution there was to lower the damper rod by roughly 10 millimeters relative to the vehicle body. So the very first idea was in fact like something like a 10 millimeter plate between this on top of the existing top mount. But in the end, the final solution was to just redesign the top mount and have this like plastic insert, and you can even see the indents on the top mount to make sure that this plastic ring is stays in place. And all of this is to make sure that this very much larger nut is lowered relative to the vehicle body, so that this pokes through the hole without causing any issues. And the electrical connection is provided by this integrated connector. So there's an integrated connector inside this hollow rod, this connector on the vehicle side goes through from the top, and during assembly the damper rod is held still using this hexagonal shape on the top. So the damper rod is held using the hexagon, and the nut is then tightened. Problem is, this causes some issues because it reduces the rear suspension travel. So with the rod and lower face of the top mount lowered, so you have to lower the lower face of the top mount in order to allow the lower mounting of the nut, you reduce the rear suspension travel. So as mentioned before, the dampers interact with what's called a jump bumper or bump stop, and they cause a non-linear suspension rate. So if it was just the mainspring, then you have a nearly perfectly straight line in terms of at where the slope is the stiffness, and that's just derived from the mainspring stiffness and the motion ratio. But with the bump stop, which starts to engage after a certain amount of bump travel, the spring rate is increased quite a bit, and at a certain point the forces become so high that the suspension cannot compress anymore, and that's how the bump travel is limited. Plus, it has to be limited to avoid destroying the internal parts in the damper. But the problem is, so then the bump stop itself is an elastomer part with its own force deflection curve, and the way I've drawn it here is so that you can see that this force is basically what gets added on top of the force coming from the mainspring, and the bump stop has a certain length, or it has a certain free length, and the more you start to compress it, the higher the compressive force coming from it, obviously. So if we didn't do anything and we just lowered the top mount, then the engagement point will come in a lot earlier, and therefore reduce the suspension travel, and that would obviously not be acceptable to the customer, because the less suspension travel you have, the worse the comfort, but also the worse the road holding. Oh. Excuse me. And yeah, for a vehicle like the Ford Focus RS, road holding is very important. So how do you solve a problem like this? Well, the solution was to create a new bump stop where the curve from the ST bump stop was simply shifted by about 10 millimeters to the right. This means that in the free length was about 10 millimeters less, but importantly, the compressed length was also about 10 millimeters less. And the way this was achieved was by using a less dense elastomer. And here I must pay compliments to the engineers and the engineering capability of a company called BASF, who were the suppliers of this part. So by using this new bump stop together with the lowered top mount with this ring insert, the issue with the clearance with the hole was solved, and also the suspension travel was retained. So retained in the sense that it was the same as the same in bump as on the Focus ST. So there was one final challenge, number 4, which was that there was no place for front wiring. And in fact, early on in the project, the engineer from Ford, one engineer from Ford actually asked me whether I could move the internal control valve, which was inside the damper, to the outside of the damper. So yeah, I said, well, I cannot really do that, but maybe if you tell me what's the real problem, I can help you solve it. And so the situation was that there was a strut brace that covered the front top mounts and left no room for the cable exit due to the minimum bending radius that you need on the cable. So there was this black sheet metal strut brace on top of the top mounts, connecting the two top mounts of the front struts, and as you can see, it's not really leaving much space underneath. So imagine this black part would cover the top mount, and so you have a small, very small amount of clearance above the damper rod and the nut to this metal sheet. So and if you remember, on the rear we had this integrated connector solution where there's a hexagon above the thread on the damper, and if you imagine some wiring coming out or a connector, there's no place for any of that here on the front. So how do you solve a problem like that? So this needed another, I would say, creative solution, which was to just get rid of that hexagon, but then you need some way to hold the damper rod still as you tighten the nut on the top mount. And so the hexagon was eliminated. The damper rod itself had some flat faces, some flat edges, which were held still by this cup inside the top mount. And you see these holes on the edge. Well, those were used to then fix this top mount cup so that the nut could be tightened. So whereas in a regular Ford Focus front top mount, the hole in the middle could be was round, because there's like an inner hexagon in the damper rod. In the case of the Ford Focus RS, it was not round but with flat edges. So imagine you have a circle, but then you just cut off two sides to create flat edges, with the damper rod sticking through and therefore fixed relative to the cup, so that the cup could be fixed and the damper rod would be fixed so that the nut could be tightened. And so with this final vehicle packaging problem solved, the project could be sold to the Ford management, after which Ford nominated Tenneco for this project. And it was a very intense number of months. So I think luckily I had the support of some great ex-colleagues at Tenneco, to help come up with these solutions, and I believe the entire process was roughly took from damper tuning for the demo drive until solving these problems. It was over a period of roughly 4 months. After that, many dampers tuning sessions followed, and of course the project grew. The project team grew a lot. There were after that many more problems had to be solved in terms of manufacturing and structural integrity of the damper, and just regular development things, but they had to be solved. And it was a very intense period of work that I look back on proudly. Hope that was interesting. Probably the next video will be more like the regular content, but this was one I wanted to make to commemorate my time working for Ford. And so hope it was interesting. Until next time.